There is a particular kind of dream that does not feel like a dream at all. It feels remembered. You wake from it with the strange sense that you have just returned from somewhere, that the room you were standing in moments ago was as solid as the one you now find yourself in. The faces in it were faces you knew. The light through the window fell in a way that seemed entirely accurate. And then, slowly, the details begin to fade, the way a name fades when you stop trying to recall it. And within a few minutes, the whole landscape is gone, leaving only the impression that you were, for a little while, somewhere else. Nearly every human being who has ever lived has had this experience. It is among the oldest mysteries we possess. And for thousands of years, in nearly every culture on Earth, there has been a quiet suspicion that dreams are not merely the noise of a sleeping brain, but a window onto something that exists, that the people we meet in them are not invented from nothing, that the rooms we walk through are not generated by accident, that somewhere, in some sense we have never been able to articulate, the dream is real. Modern physics has not confirmed this, but it has done something stranger. It has produced, almost as an unintended consequence of trying to make sense of the very small, a picture of reality in which parallel worlds are not only possible, but mathematically natural. A picture in which every quantum event that could go one of several ways may go all of the several ways at once, in branches of the universal wave function that exist alongside our own. A picture in which there is, somewhere, a version of you who took the other job, who turned left instead of right, who never woke from the dream you had as a child of being lost in a field of tall grass with the sun going down. This is the territory we will be moving through. Slowly, without urgency, the way one moves through a dream itself. It is worth saying at the outset that the idea of dreams as glimpses of other realities is not a scientific claim that has been established. No experiment has shown that the images appearing behind closed eyelids during the night are reaching us from elsewhere. The neuroscience of dreaming, as we will see, has a great deal to say about how dreams are constructed inside the sleeping brain, and most of what it says has nothing to do with parallel worlds. And yet, when one places the science of dreams alongside the science of quantum reality and lets them sit together in the quiet, certain resonances emerge that are difficult to dismiss entirely. The mind, in sleep, behaves in ways that no other mind we know of behaves. The universe, at its smallest scales, behaves in ways that no other system we have ever encountered behaves. And the question of how these two strangenesses might be related has been with us, in one form or another, for a very long time. The Sumerians wrote about it on clay tablets 5,000 years ago. The ancient Egyptians built temples where one could go to sleep deliberately, hoping that something useful would arrive in the dark. The Greeks believed that dreams entered the house through a particular gate and could be either true or false, depending on which gate they came through. The philosopher Aristotle, characteristically, was skeptical and suggested that dreams were merely the residue of waking sensation. But even he could not quite explain why so many people, across so many centuries, kept reporting that something significant had visited them in the night. To begin to think about this carefully, we need to set the scene. We need to understand, first, what is happening in the brain when it dreams. Then we need to understand what is happening in the universe at the level where reality begins to fray into possibility. And then, very gently, we can begin to ask how these two things might be related, if at all, and whether the old human intuition that dreams open onto something larger has any echo in the science of our own time. There is no hurry. The night is long. Sleep itself is one of the strangest things we do, Every creature with a complex nervous system seems to do it in some form. Fruit flies sleep, octopuses sleep, and even appear to dream in a way that involves rippling color changes across their skin, as if rehearsing some performance whose audience does not exist. Birds sleep with one half of their brain at a time, gliding through the night sky on slow wings while the other half rests. Dolphins do the same. The pattern is so universal, so ancient, that biologists have long suspected sleep must be doing something extraordinarily important, something that simply cannot be done while the organism is awake. What that something is, no one entirely knows. For most of human history, sleep was assumed to be a kind of small death. The body lay still, the breath slowed, and consciousness, that strange flickering candle, was extinguished until morning. The Greek god Hypnos was the brother of Thanatos, the god of death, and the resemblance was thought to be no coincidence. Sleep was the antechamber of the underworld. Dreams were what one saw from that threshold. It was not until the middle of the 20th century that science began to understand that sleep is not a single state at all, but a sequence of states, very different from one another, that the brain cycles through several times each night. In the early 1950s, two researchers at the University of Chicago, Eugene Asarinsky and Nathaniel Kleitman, were studying the eye movements of sleeping subjects. They noticed that, periodically through the night, the eyes beneath the closed lids would begin to dart back and forth, rapidly, as if watching something. When the sleepers were woken during these episodes, they almost always reported having been in the middle of a vivid dream. The phenomenon was called rapid eye movement, and the stage it marked is now known as REM sleep. REM sleep is one of the strangest things the brain does. During it, brain activity, measured by electrical recordings of the scalp, looks almost identical to the brain activity of someone wide awake. The visual cortex fires busily, generating images. The emotional centers, particularly the amygdala, light up. The hippocampus, the brain's archivist of memory, is also active. And yet the body, with the exception of the eyes and the small muscles of breathing, is essentially paralyzed. A clever mechanism in the brainstem disconnects the cortex from the motor neurons, preventing the dreamer from acting out the dream. When this mechanism fails, in a condition known as REM behavior disorder, sleepers will leap from bed, fight invisible enemies, or have whole conversations with people who are not there. A typical adult cycles through several stages of sleep 4 or 5 times each night. Each cycle takes about 90 minutes. The first cycles are dominated by deep, slow-wave sleep, the restorative kind that is thought to clear metabolic waste from the brain and consolidate certain kinds of memory. As the night progresses, the REM episodes become longer and more elaborate. The longest, richest dreams of the night tend to occur in the last hour or two before waking, which is why we so often remember them. We surface from these dreams the way a swimmer surfaces from deep water, the strange landscape still clinging to us as we rise into morning light. Most dreams occur during REM sleep, though not all. People can dream in a quieter and more thought-like way during the deeper stages too. But it is during REM that the brain produces those long, narrative, often bizarre experiences we usually mean when we say that we dreamed. Brain imaging studies have shown that during REM sleep, particular regions of the cortex are highly active while others, notably the parts of the prefrontal cortex involved in critical reasoning and self-awareness, are relatively quiet. This is thought to explain why dreams, no matter how strange, seem perfectly believable from the inside. The part of the brain that would normally say, "Wait, this doesn't make sense," has gone temporarily offline. We accept the dream's logic the way a fish accepts water. Why the brain does this every night, for an hour or two at a time, year after year, decade after decade, no one entirely knows. Several theories have been proposed, and each captures part of the truth, though none of them captures it all. One of the oldest scientific theories of dreams comes from the work of the American psychiatrists Alan Hobson and Robert McCarley, who in the 1970s proposed what they called the activation synthesis hypothesis. In their view, dreams are essentially the brain's attempt to make sense of random neural firing during sleep. The brainstem, they suggested, sends bursts of activity up to the cortex during REM sleep, and the cortex, which has no idea where these signals came from, weaves them into a coherent story. The way the eye will sometimes find a face in a cloud. On this view, dreams are not messages. They are the brain doing what it always does, looking for patterns, and finding them whether they are there or not. The activation synthesis theory was a major step forward because it grounded dreams firmly in neurophysiology, but it has been challenged in the years since by researchers who point out that dream content is not as random as the theory predicts. Dreams often connect, in subtle and indirect ways, to things that happened in the dreamer's recent waking life. Dreams often grapple with emotional concerns that the dreamer has been preoccupied with. Dreams often, in fact, seem to be doing some kind of work. This led to a different family of theories, sometimes grouped under the heading of memory consolidation. The basic idea is that, during sleep, the brain replays and reorganizes the experiences of the day, integrating new information into the vast network of older memories. A great deal of evidence now supports some version of this view. In experiments with rats, researchers have shown that neurons in the hippocampus, which fire in particular patterns as the rat navigates a maze, fire again in the same patterns during subsequent sleep, as if rehearsing the route. A similar replay has been observed indirectly in the human brain. People who dream about a task they have just learned tend to perform better on it the next day than people who do not. Whatever else dreams are doing, they appear to be involved in the slow work of turning experience into knowledge. A third theory, advanced most forcefully by the Finnish psychologist Antti Revonsuo, holds that dreams evolved as a kind of threat simulation. On this view, our ancestors who dreamed about dangerous situations and rehearsed escape and combat were more likely to survive the next encounter with a predator or a hostile neighboring tribe. The dream is a virtual training ground, a simulator in which the most dangerous scenarios can be played out without any real risk. This would explain why dreams so often involve being chased, falling, fighting, fleeing, or losing track of someone we love. These are not random anxieties. They are the rehearsals of an animal that has, over a few million years, gotten very good at staying alive. And yet, none of these theories accounts for everything. They do not explain why dreams are so often beautiful. They do not explain the moments of unaccountable joy that sometimes arise in them, or the encounters with figures who feel both unknown and intimately familiar. They do not explain the dreams that seem to deliver insights. The dreams that have, in well-documented cases, given scientists and artists ideas they could not have reached while awake. The chemist Friedrich August Kekulé reportedly arrived at the ring structure of benzene after dreaming of a snake biting its own tail. The mathematician Srinivasa Ramanujan described receiving theorems from a goddess in his sleep. Whether these stories are exactly accurate or somewhat embellished, the phenomenon they describe is real enough. The sleeping mind sometimes produces things the waking mind cannot. So what precisely is happening behind the closed eyes of a dreamer? The honest answer is that no one knows in full. The brain is generating an immersive experience, complete with sight and sound and emotion, and a sense of being a self moving through a world. It is doing this without external input. It is doing this while the body is paralyzed and the prefrontal critical faculties are quieted. And it is doing this every single night, in nearly every human being who has ever lived, and apparently in many other animals as well. That alone would be remarkable. But there is more. To approach the question of whether dreams might glimpse parallel realities, we have to take a long detour into the strangest territory in all of physics. We have to talk about quantum mechanics. And we have to talk about it slowly, gently, because it is an idea that does not behave the way ordinary ideas behave. It does not let itself be pinned down with words. It slips between them for a very long time. Until the early years of the 20th century, physics was a story about objects. There were planets, and they moved along orbits. There were apples, and they fell from trees. There were billiard balls, and they bounced off one another according to laws so reliable that, given enough information, one could predict precisely where every ball in a game would be at any future moment. The universe in this picture was a great clockwork. Each gear engaged the next. The future was already implicit in the present, hidden only by our ignorance of all the details. Then came the atom, and everything changed. When physicists in the early 20th century began to probe the structure of matter at scales below the visible, they discovered that the inside of an atom did not behave like a small solar system, or like anything else they had ever encountered. The electron, that minute particle whose dance around the nucleus determines the chemistry of everything we see, did not have a definite position. It did not have a definite velocity. It seemed to be, in some way that defied ordinary language, in many places at once, with a probability distribution describing where it might be found if one looked. And when one did look, the distribution collapsed, and the electron was there at one particular point and not elsewhere. This was strange enough, but it got stranger. In an experiment that has been repeated thousands of times in different forms, physicists fire single particles, one at a time, at a barrier containing two narrow slits. On the far side of the barrier, a detector records where each particle lands. If the particles behaved like tiny bullets, one would expect them to pile up in two stripes, one behind each slit. They do not. They produce, instead, a pattern of light and dark bands, the kind of pattern one sees when two waves on the surface of a pond meet and interfere with each other. The conclusion is unavoidable. Each particle, passing through the apparatus alone, somehow behaves as a wave. It passes through both slits. It interferes with itself. And here is the part that has unsettled physicists for a century. If one places a detector at the slits to see which slit each particle actually passes through, the interference pattern vanishes. The particles begin to behave like bullets again, piling up in two stripes. The mere fact of having looked changes the outcome. The unobserved particle moves through the world as a wave of possibility. The observed particle commits to a single trajectory. This is the heart of the measurement problem in quantum mechanics, and 100 years of intense thought have not entirely solved it. What does it mean to say that a particle is in many states at once until observed? Who or what counts as an observer? Where exactly does the line lie between the quantum world of fuzzy possibility and the classical world of definite fact? The most widely taught answer is the so-called Copenhagen interpretation, named after the Danish city where the physicist Niels Bohr did much of his work. On this view, the wave function, the mathematical object that describes the spectrum of possibilities for a quantum system, is not a physical thing. It is a tool for predicting probabilities. When a measurement is made, the wave function collapses to a single outcome, and that is all there is to say. The other possibilities simply vanish. They were never real. Many physicists, then and since, have found this answer deeply unsatisfying. It leaves the act of measurement as a kind of magical event, unexplained by the underlying physics. It suggests that the universe, when nobody is watching, exists in a smeared-out haze of probability, which then somehow snaps into focus when a conscious being takes a look. Albert Einstein famously could not accept this. He asked whether the moon was really only there when someone happened to be looking at it. To him, the Copenhagen view abandoned the realist core of what science was supposed to be doing. The universe, he insisted, must have a definite state, whether anyone is observing it or not. It was in this climate of unresolved unease that a young graduate student at Princeton University, in the middle of the 1950s, came up with a different idea. His name was Hugh Everett III. He was 25 years old, brilliant, contrarian, and a chain smoker. He was working under the supervision of John Archibald Wheeler, one of the great physicists of the 20th century, and he proposed something that, in retrospect, seems both very simple and almost too strange to be true. What if, Everett asked, the wave function does not collapse at all? What if, when a measurement is made, every possible outcome actually occurs, each in its own branch of reality? What if the cat in Schrödinger's famous thought experiment, the cat in the sealed box with the radioactive atom and the vial of poison, is not partly alive and partly dead until someone opens the box? What if instead, when the box is opened, the universe simply splits? In one branch, the observer sees a living cat. In another, the observer sees a dead cat. Both observers are real. Both cats are real. Neither knows about the other. The wave function never collapses. It simply continues, with each outcome carried forward in its own world. Everett wrote up this idea in his doctoral dissertation in 1957. A shortened version was published that year in the Journal Reviews of Modern Physics under the title Relative State Formulation of Quantum Mechanics. The response was almost complete silence. Wheeler, who had encouraged Everett to develop the idea, did try to interest his colleagues in Copenhagen, but Niels Bohr and the older generation of physicists rejected it out of hand. Everett himself, frustrated and disappointed, left academia almost immediately for a career in defense research. He never published another paper on quantum mechanics. He drank too much. He died of a heart attack in 1982 at the age of 51. But the idea did not die with him. In the 1970s, a physicist named Bryce DeWitt rediscovered Everett's work and gave it the name by which it is now known. He called it the many worlds interpretation. And over the decades that followed, as new generations of physicists came to grips with the foundational puzzles of quantum theory, the many worlds view gained ground. Today, it is taken seriously by a substantial fraction of working physicists. Some, like the British physicist David Deutsch of Oxford University, regard it as not merely an interpretation, but the only coherent description of what the mathematics of quantum mechanics actually says. Others remain skeptical, pointing out that the existence of these other branches cannot, by their very nature, be directly verified. The matter is still debated. It is important to be careful here. The many worlds interpretation is a real scientific proposal, taken seriously by reputable physicists. But it is not an established fact. There are alternative interpretations, including the original Copenhagen view, the so-called pilot wave theories developed by David Bohm, and several others. The mathematical predictions of quantum mechanics are agreed upon and have been confirmed by experiment to astonishing precision. What is disputed is what the mathematics means, whether the other branches of the wave function are real in the same sense that this branch is real is a question that remains open. But suppose, for a moment, that they are. Suppose Everett was right, then every choice that has ever been made, by you, by anyone, by anything, has gone every possible way. Every quantum event in the early universe that could have unfolded differently has unfolded differently in some other branch. Every coin that was ever flipped landed on both heads and tails. The cosmos is not a single thread, but a vast, branching tree of possibility. And the trunk we live on is only one of an unimaginable number of equally real paths. In some of those paths you exist. In some you do not. In some you exist, but your life took a different turn. In some cases, the dinosaurs were never hit by an asteroid. In some, the asteroid hit, but the dinosaurs survived. In some, the Earth itself never formed. This is the picture that Everett's mathematics, if taken seriously, suggests. And it is here, in this picture, that the old question about dreams begins to whisper again. It is worth pausing here because the night is long and the ideas have been heavy, and there is no need to rush. Consider what we have so far. The brain, in sleep, generates entire worlds. Coherent, immersive, internally consistent worlds. Worlds populated by people, by landscapes, by weather, by buildings whose architecture is sometimes more detailed than anything the dreamer has ever consciously studied. The brain does this nightly for an hour or two at a time, with no external input. The brain does it well enough that, while it is happening, we accept the dream as reality. We do not, in the moment, doubt it. We doubt only afterward, when we wake. And then consider what physics tells us about the underlying nature of the world we wake into. That this world, the one in which we stir and stretch and reach for a glass of water by the bed, may be only one of vastly many. That the mathematics that has correctly predicted every quantum experiment ever performed contains, if one takes it at face value, a description of branches in which we are not stirring at this moment, branches in which we never woke at all, branches in which we are doing something else entirely. The question naturally arises, is there any connection? Could the worlds we visit in dreams be the worlds that mathematics is describing? Could the strange continuity of dream landscapes, their feeling of being not invented but encountered, be a faint echo of branches in the wave function whose details, by some mechanism we do not understand, occasionally reach us? The honest scientific answer is that we do not know, and that there is no current evidence to suggest such a thing. The neural processes that generate dreams appear, by every measurement we can make, to be perfectly local. The firing of neurons in the dreaming brain is doing what neurons always do. There is no observed channel by which information from another branch of the wave function could enter the dreaming mind, and the many worlds interpretation, even if correct, predicts that the branches do not interact. Once they separate, they go their own ways. The branch in which the dinosaurs survived is, by the standard formulation, completely inaccessible to us, not just hidden, not just far away, inaccessible in a much deeper sense, like a number that cannot exist. So if dreams are not actually opening windows onto other branches of reality, why does the idea persist? Why has nearly every culture in human history come to suspect that dreams come from somewhere? Why do dreams so often feel, in the moment, like discoveries rather than inventions? there is a possible answer that does not require any actual contact between branches. It has to do with the nature of imagination itself, and the strange fact that the human mind appears to contain, in some sense, a model of all the worlds it could be living in. We rehearse what we have not yet done. We mourn what has not yet happened. We are constantly simulating, in our waking moments, and even more vividly in sleep, the alternative paths our lives could take. The branches of possibility are present, at least as mental representations, inside the brain itself. The dreamer is not visiting another reality. The dreamer is visiting the brain's own internal model of all the realities that might have been, or might still be. But this answer, which is probably correct, is not quite as deflationary as it sounds. Because the brain's capacity to model alternative realities is itself one of the most extraordinary facts about us. We are alone among the species we know, creatures that can fully inhabit experiences that are not happening. We can be in our minds, in places we have never been. We can be in our minds, people we are not. We can rehearse our own deaths and the deaths of those we love in advance. We can travel on the strength of a few thousand neurons firing in particular patterns to the surface of a moon we will never set foot on. This is not a small ability. This is, in some sense, the ability that defines us, and dreams are perhaps the purest expression of it. In dreams, the simulation runs without external constraint. The brain, freed from the obligation to track the actual world, lets the worlds it might be tracking come forward and play. The result is the nightly festival of alternative experience that every human being attends, whether they remember it in the morning or not. So perhaps the old intuition was not exactly wrong. Perhaps it was wrong only in the literal sense. The dream is not a window onto another universe in the strict scientific meaning of that phrase, but it is a window onto the universe of all the things that could have happened, all the people who could have been, all the places where life might have gone differently. The brain, in sleep, opens this archive and walks through it. Some of what it finds there is recent, drawn from the day. Some of it is very old, drawn from childhood. Some of it is so deeply structured into the architecture of the species that the same images appear in dreamers from cultures that have never met, the way the same patterns appear in the leaves of unrelated trees. This is the territory that the Swiss psychiatrist Carl Jung spent his life mapping. Jung, working in the early 20th century, became convinced that beneath each individual's personal unconscious, with its private memories and forgotten faces, there lay a deeper layer, shared by all human beings. He called it the collective unconscious. He believed that it contained certain primordial images, which he called archetypes, that recur in dreams and myths across all cultures. The wise old man, the great mother, the hero, the shadow, the journey, the flood. Jung saw these as the deep structural elements of the human psyche, present in all of us by virtue of being human. The way the basic plan of the human body is present in all of us by virtue of belonging to our species. Jung's collective unconscious is not a scientific theory in the modern sense. It cannot be measured. It cannot be falsified by experiment. Most contemporary neuroscientists and psychologists do not accept it as a real phenomenon, but the patterns Jung pointed to are real. The same kinds of figures do appear in dreams across very different cultures. The same kinds of narratives do recur in myths around the world, whether this is because of some shared psychic substrate, or because the human brain is built in such a way that it tends to produce similar imagery under similar conditions, is a question that remains open. Either way, the dream, when one looks closely, does not seem to be drawing only from the dreamer's personal experience. It is drawing from something larger. Let us now go further out, away from the brain and into the cosmos, and see what physics has to say about the size of the stage on which all of this is happening. For most of human history, the universe was thought to be small. The Earth was at the center. The sun, moon, and planets moved around it on crystal spheres. Beyond the spheres of the planets lay the sphere of the fixed stars, a kind of cosmic ceiling onto which the stars were attached like distant lamps. Beyond that, depending on one's tradition, lay either the realm of God or simply nothing at all. The cosmos was finite, ordered, and not very large. The transformation of this picture is one of the great stories of the modern age. In the 16th century, Nicolaus Copernicus moved the Earth from the center to a place among the other planets. In the 17th century, Galileo turned his telescope to the sky and saw mountains on the moon, moons around Jupiter, and a Milky Way that was not a band of cloud, but a vast assembly of individual stars too numerous to count. In the 19th century, the slow work of measuring stellar distances began, and astronomers realized that even the nearest stars were unimaginably far away, that the light reaching us from them had been traveling for years before it arrived. In the early 20th century, the picture expanded again. Edwin Hubble, working at the Mount Wilson Observatory in California, was able to show that certain faint smudges of light in the night sky, called nebulae, were not gas clouds within our own galaxy, but separate galaxies of their own, each containing hundreds of billions of stars. The universe was suddenly understood to be vastly larger than anyone had imagined, and it was getting larger. Hubble found that the more distant galaxies were moving away from us, faster the farther they were. Space itself was expanding. Today, the observable universe is understood to be a sphere some 93 billion light-years in diameter, centered on the Earth. This sounds like a contradiction. The universe is only about 13.8 billion years old, and nothing can travel faster than light. How can the observable universe be wider than the distance light could have traveled in that time? The answer is that space itself has been expanding while the light was in transit. The light that left a distant galaxy 13 billion years ago was, at the time, much closer to us than it is now. By the time it arrived, the galaxy that emitted it had been carried, by the expansion of space, to a current distance of around 46 billion light-years. Twice that gives the diameter of the observable sphere. The observable universe is thought to contain, by current estimates, around 2 trillion galaxies, each home to hundreds of billions of stars. The total number of stars in the observable universe is somewhere in the neighborhood of 10 to the power of 24, which is to say, a 1 followed by 24 zeros. That is more stars than there are grains of sand on every beach on Earth. A great many of those stars have planets. A significant fraction of those planets is roughly the size of Earth. An unknown number of them lie in zones where liquid water could exist on the surface. Whether any of them harbor life, no one yet knows. But this is only the observable universe. The full universe, if our best models of cosmology are correct, is much larger. Possibly very much larger. Possibly infinite. In the late 1970s and early 1980s, a young physicist named Alan Guth proposed an idea that has become a cornerstone of modern cosmology. It is called inflation. The idea is that, in the first tiny fraction of a second after the Big Bang, the universe underwent a period of extraordinarily rapid expansion. In far less than a second, by a factor that staggers the imagination, the universe grew. This expansion smoothed out whatever lumps and irregularities had been present in the initial state, and it stretched the universe to a size far, far larger than the part we can now see. The Russian-American physicist Andrei Linde, working independently and along similar lines, refined this picture in ways that have profound implications. In what is now called eternal inflation, the inflationary process never entirely ends. In most of the universe, inflation continues, generating new regions of space at an ever-increasing rate. In some pockets, inflation stops, and a hot, expanding region of ordinary matter and radiation forms. Our observable universe is one such pocket, but there are others, many others, possibly infinitely many. This is the picture that the cosmologist Max Tegmark has called the Level 1 and Level 2 multiverse. The Level 1 multiverse is the simplest version. If space is infinite, or even just very large, then there are vast regions far beyond our observable horizon, where matter has arranged itself into stars and galaxies, just as it has here. Somewhere out there, by the logic of probability over infinite space, there are regions identical to our own. Identical galaxies, identical stars, identical planets, identical to you. Tegmark has estimated that a region identical to our own observable universe should exist, statistically, at a distance of about 10 to the power of 10 to the power of 118 meters away. That number is not just large. It is incomprehensible. It cannot be visualized. It cannot be meaningfully compared to any other quantity in nature. But if the universe is infinite, it is, in some sense, just a number, and the duplicates exist. The Level 2 multiverse goes further. In eternal inflation, different pocket universes may have different physical constants, different strengths for gravity, different masses for the elementary particles, different numbers of dimensions even. Most of these pockets would be sterile. Stars could not form. Atoms could not exist. But somewhere, in a tiny fraction of the vast ensemble, the constants would land in the narrow range that permits chemistry, biology, and observers like us. And then there is the Level 3 multiverse, which is simply Everett's many worlds applied to cosmology. Every quantum event branches. Every possible outcome occurs. The wave function of the universe continues to grow more and more elaborate, and the branches accumulate. And somewhere on every branch, there are beings asking themselves whether the other branches are real. There is even a Level 4, which Tegmark himself proposed, in which all mathematically possible structures correspond to real universes. But this is the most speculative end of the spectrum, and we need not linger on it. What matters for our purposes is the size of the picture. Even the most cautious version of modern cosmology suggests that the universe is, at minimum, vastly larger than the part we can see. The more ambitious versions, supported by the mathematics of inflation and of quantum theory, suggest that the totality of what exists is so vast as to defy any meaningful measure. There is room in this picture for any conceivable possibility. There is room for every dream that has ever been dreamed to be, somewhere, the local truth of some region of space and time. This is not the same as saying that dreams reach those other regions. They almost certainly do not. The signals would have to cross vast distances or pass between branches that, by the mathematics, do not communicate. But the picture provides a kind of cosmic backdrop against which the old intuition no longer seems quite as foolish. The universe is, at the very least, the kind of place where there could be parallel realities. Whether the night brings us echoes of them is a question we cannot answer. But we can sit with the question. We can let it rest in the dark room with us, the way we let any old, unanswerable thing rest, without forcing it into a shape it does not want to take. Sleep itself, even without dreams, is a kind of journey. It takes us out of the world we know and returns us, after a few hours, slightly changed. The room is the same when we wake. The sheets are warm where we lay, but something has happened in the interval. Memories have been sorted. Connections have been made. The neurons that were busy yesterday have, in some sense, rested, and the neurons that need to come online for tomorrow have been prepared. We do not feel the work happening. We feel only the difference between going to bed tired and waking up rested. The work is silent. The work is done in the dark, and during some of those hours, especially in the second half of the night, the world that the brain generates in the absence of waking input becomes vivid enough to remember. The dream begins. It usually begins without any clear opening. We are not aware of arriving in it. We are simply there, in some place we have not seen before, doing something we did not plan to do, and the dream goes on as if it had always been going on. There is no establishing shot. There is no entry. The dream is simply present, the way a thought is simply present. What is going on in the brain during this? We can describe it in some detail, though much remains uncertain. The visual cortex, the great expanse of neural tissue at the back of the head that processes what the eyes see, is firing in patterns that resemble, though do not exactly match, the patterns it produces when the eyes are open. The brain is, in effect, watching something. But what it is watching has been generated by the brain itself. There is no light entering the eye. There is no scene being projected on the retina. The scene is being assembled inside the skull, from memory and association, from patterns the brain has learned, from raw material the brain has been collecting for as long as the dreamer has been alive. The hippocampus is involved. This is the brain's archivist. During the day, it records the experiences we have. During sleep, it appears to replay them. In studies with animals, neurons in the hippocampus that fired in particular sequences as the animal explored a new environment have been observed to fire again, in the same sequences, during subsequent sleep. The brain is rehearsing. The brain is rehearsing the day. And in human dreams, fragments of the recent day frequently appear, often slightly altered, often mixed with material from much further back. The amygdala, the brain's emotional center, is also highly active during REM sleep. This is probably why dreams are so often emotionally charged. Fear, longing, embarrassment, love, these feelings, which during the day might be moderated by the more analytical parts of the brain, run free during the dream. The result is the strange emotional vividness of the dream world, the way the smallest detail of a dream can carry a weight of feeling that would be excessive in waking life. Meanwhile, the prefrontal cortex, the region that during waking evaluates what is sensible and what is not, has gone unusually quiet. It is not entirely shut off, but its critical voice is muffled. This is why the dreamer, encountering some clearly impossible event, accepts it without question. A friend who died last year is suddenly there in the kitchen, and the dreamer feels only a flicker of mild surprise. A staircase opens out of a wall, and the dreamer climbs it. The part of the mind that would normally object has, for the moment, stepped away. There is another piece of this picture worth mentioning, because it appears in some recent research and has its own quiet wonder. The default mode network, a constellation of brain regions that is most active when the mind is wandering, daydreaming, thinking about the past or the future, or about other people, remains active during REM sleep. The default mode network is, in some sense, the brain's storyteller. It is the part that builds narratives, that imagines, that places us inside scenes that are not happening. And during sleep, with the external world absent and the critical voice quieted, The default mode network continues to do what it does best. It tells a story, and the dreamer is inside that story. This is one of the reasons that dreams feel so much like glimpses of something rather than productions of one's own. The same machinery that, during the day, lets us imagine other places, other people, other possibilities, is running in sleep without the constraints that waking imposes. It is unbound. It is free to roam. And the worlds it produces are detailed enough, coherent enough, immersive enough that the dreamer experiences them as real. Of course, this does not mean the worlds are real in any external sense. It means only that the brain is very, very good at making them feel real. But the question remains, gently, in the back of the dreamer's mind, every time they wake from a dream that did not feel invented. Where did that come from? Why did it feel so much like a place I had visited rather than a place I had made? Why do I remember the corners of rooms I have never been in? There is a thought experiment that has gone around philosophical and physical circles for some decades. It concerns the question of whether what we call reality is the only kind of thing that could rightly be called reality, or whether other kinds of structures, generated by minds or by other processes, might count as well. Consider a video game. Inside the game, if it is sophisticated enough, there are characters who walk around, who solve problems, who form relationships with one another. From the inside, the world of the game has its own laws, its own geography, its own time. The characters, if they were conscious, would experience that world as their reality. They would not, generally, have access to the fact that they exist as patterns of computation in a machine outside their world. This thought experiment was made famous by the philosopher Nick Bostrom in a paper published in 2003. Bostrom argued, on certain assumptions about the future of computing and the prevalence of advanced civilizations, that it is statistically likely that we ourselves are characters in such a simulation. The argument is controversial, and not everyone accepts the assumptions. But the broader idea that what counts as real may depend on the level at which one is asking the question has a long philosophical history. The ancient Taoist philosopher Zhuangzi told a story of dreaming he was a butterfly, and then wondering, on waking, whether he was a man who had dreamed of being a butterfly, or a butterfly now dreaming of being a man. The dream, on this view, is not a glimpse of another world. The dream is its own world, and from the inside, while it is happening, the dream is as real as anything else. This is not, perhaps, the most comforting thought, but it is also not the most disturbing one. Reality, in modern physics, has a way of turning out to be more layered than any of us had supposed. The solid table you might be sitting at right now is, at the level of its atoms, almost entirely empty space, with tiny dense nuclei separated by enormous distances, and surrounded by clouds of probability that we call electrons. The light that lets you see the table is not a substance traveling through space, but, by certain measurements, a wave in fields that fill all of space, and by other measurements, a stream of particles. The very passage of time, in Einstein's relativity, depends on the speed at which you move and the strength of the gravitational field you happen to be in. There is no single, absolute clock ticking out there. There is your clock, and there is mine, and they are not the same. Given all this, it is perhaps not so strange to consider that the world of dreams might have a kind of reality of its own, even if it is not the kind of reality that physics knows how to describe. The brain that produces a dream is real. The neurons firing are real. The patterns they trace are real. And from the inside, while the dream is happening, the dreamer is having an experience that is, by any honest measure, real to them. It does not become less real on waking. it becomes less accessible. The night has gone on, and so have we, and the ideas have grown gentler as they have grown stranger. Let us return to the question with which we began. Are dreams glimpses of parallel realities? The literal answer, the answer that current science would offer, is no. The dreaming brain is a local thing. It produces its experiences through local mechanisms, using materials drawn from the dreamer's own memory, the dreamer's own associations, and the dreamer's own evolutionary heritage. The other branches of the wave function, if they exist, do not appear to communicate with our branch. The other regions of an infinite universe, if it is infinite, lie far beyond any conceivable channel of communication. By the standard scientific picture, the dreams that visit us at night are productions of our own brains and nothing more. But the standard scientific picture is not the whole picture. It is, by its own admission, incomplete. We do not understand consciousness. We do not fully understand the measurement problem in quantum mechanics. We do not understand why the universe seems so finely tuned for the emergence of complexity and life. There are large gaps in our knowledge, and any of those gaps, in principle, could contain surprises that change the picture. The history of science is, in part, a history of surprises that changed the picture. A century ago, no one knew that atoms had a structure, that galaxies existed beyond our own. That information could be encoded in molecules and copied with extraordinary fidelity. A century from now, who can say what will be known that is not known now? So perhaps the more honest answer is that, by the best science of our time, dreams are not glimpses of parallel realities, but we cannot rule it out absolutely. And there is something about the experience of dreaming that resists the deflationary explanation. Even if every dream is fully accounted for by the firing of neurons, there is still the strangeness of what it is like to be inside one. There is still the morning sense of having returned from somewhere. There is still the old human intuition, present in the earliest writings of every culture that has left writings, that dreams are coming from somewhere larger than ourselves. This intuition may be the residue of an ancient mistake, a leftover of a time when the boundary between the self and the world was less clear, when the figures in our dreams were taken for gods or messengers or spirits, because we had not yet developed the conceptual tools to recognize them as products of our own minds. Or it may be that the intuition is pointing at something subtle that we have not yet understood. Both possibilities are open. Both deserve respect. The point, perhaps, is not to settle the question, but to sit with it. The dream is real, in the only sense that ultimately matters, which is that it is experienced. The parallel realities suggested by quantum mechanics are also real, according to the most popular interpretations of that theory, though we cannot reach them. The universe is vastly larger than the part we can see. The mind is vastly more capable of generating experience than we ordinarily appreciate. Between these two vastnesses, the small thing that is each of us drifts off each night into something that, while it lasts, feels boundless. And then in the morning we wake, and the dream fades, and the day begins. The deeper one looks into the science of sleep, the more one finds that almost everything about it remains, in some way, mysterious. We know that we need it. We know that prolonged sleep deprivation is bad for the body and the mind, sometimes catastrophically so. Rats deprived of sleep for long enough will die. Humans deprived of REM sleep for long enough will experience hallucinations, mood disturbances, and impaired cognition. There is something in sleep that the organism cannot do without. But what precisely that something is, no one fully knows. Different researchers emphasize different aspects. Some point to the clearing of metabolic waste from the brain. During the deeper stages of sleep, the spaces between brain cells appear to widen, and cerebrospinal fluid flows more freely through them, washing out byproducts that accumulate during the day. Some point to the consolidation of memory. Some point to the regulation of mood and emotion. Some point to the restoration of immune function. All of these things appear to depend, in some way, on sleep, and all of them happen in the dark, while the dreamer is busy elsewhere. The relationship between dreams and these various functions of sleep is itself a matter of debate. Some researchers see dreams as essentially the conscious accompaniment of memory consolidation, a kind of side effect of the brain replaying the day. Others see them as more independent, as having their own evolved function, or simply their own emergent character. The neuroscientist Mark Soames has argued that dreams arise from a specific dopaminergic pathway in the forebrain, and that their function is to express, in disguised form, the urges and desires that the dreamer has not been able to fulfill during the day. This view, which is recognizably Freudian in spirit, has been controversial, but is supported by certain clinical observations. Patients who have suffered damage to the relevant brain regions, Soames found, often stop dreaming altogether, even though they continue to enter REM sleep normally. The point of recounting these various theories is not to settle on one of them. It is worth noting that, on the most basic question of why we dream at all, the scientific community has not converged on an answer. Several plausible theories coexist. None of them is universally accepted. The phenomenon remains, to a considerable degree, a phenomenon in need of explanation. And in the absence of explanation, the older suspicions, the ones recorded on clay tablets and papyrus scrolls, retain a quiet authority. They have not been refuted. They have only been set aside, pending better data. The astronomy of all this, the cosmic background against which we sleep and dream, has its own slow, beautiful rhythms. There is something restful in remembering the scale of things. The galaxy we live in, the Milky Way, is a flat spiral of gas and dust and stars, about 100,000 light-years across, rotating slowly around its own center. Our sun lies about 27,000 light-years from that center, in a quiet stretch of the Orion Arm. The sun, in turn, takes around 220 million years to make a single circuit of the galactic core. The last time the sun was in the position it occupies now, the earliest dinosaurs were just beginning to appear on Earth. The sun itself is a fairly ordinary star, midway through its lifetime. It will continue to shine, more or less as it does now, for another 4 or 5 billion years. In time, it will swell into a red giant, expanding past the orbit of Mercury, perhaps past Venus, perhaps engulfing the Earth itself before settling down into a cooling white dwarf. But that is all very far in the future. For now, the sun is steady. For now, the Earth orbits at a distance that has remained, by cosmic standards, remarkably constant. For now, the conditions on this small blue world remain, by some narrow margin, hospitable to the kinds of biology that produce dreaming brains. The Earth turns once every 24 hours. As it turns out, the side facing the sun is bright, and the side facing away is dark. The dark side is where dreaming mostly happens. As one half of the planet sleeps, the other half is in the middle of its day. The wave of sleep moves around the globe continuously, never stopping, never starting. At every moment, somewhere on Earth, some billions of brains are deep in REM sleep, generating their private worlds. The phenomenon is too vast to picture. We can only know that it is happening. Beyond Earth, our solar system contains 7 other planets, several dwarf planets, dozens of moons, and countless smaller bodies. Some of these worlds are barren. Some of them, like Europa around Jupiter and Enceladus around Saturn, are thought to have oceans of liquid water beneath their icy surfaces, oceans that may, conceivably, harbor life of some kind. Whether anything sleeps and dreams in those hidden seas, no one knows. Probably nothing does. The conditions are difficult, and the chemistry of life, if it exists there, has had a different evolutionary history. But the possibility hangs in the back of the mind, a small, quiet ornament in the larger picture. Beyond the solar system, the nearest star is Proxima Centauri, a small red dwarf about 4.24 light-years away. Around it orbits at least one planet that lies in the zone where liquid water could exist on the surface. Whether the planet actually has water, whether it has an atmosphere, whether anything lives there, is unknown. The light reaching us from Proxima Centauri tonight left it a little over 4 years ago. The starlight we see is, in a small but real sense, history. Everything we see in the sky is something we are seeing as it was, not as it is. This is one of the strangest gifts of looking up. The night sky is not a snapshot. It is a layered composition of moments, some of them recent, some of them ancient. The moon you see, if you happen to look out the window now, is the moon as it was about a second and a half ago. The light from the sun, when it rises tomorrow, will be light that left the sun 8 minutes earlier. The light from the nearest stars is years old. The light from the most distant galaxies in the Hubble Space Telescope's deep field images is billions of years old, emitted when the universe was a small fraction of its current age, when the Earth and the Sun did not exist, when the heavy elements that would eventually become the iron in our blood had not yet been forged in the cores of dying stars. When we look at the sky, we are looking at a kind of time machine. Each direction in the sky carries with it a different moment in the cosmic past. The deeper one looks, the further back in time one sees. At the very edge of what we can see, at distances of around 46 billion light-years, we are seeing the cosmic microwave background, the faint radiation left over from the moment, some 380,000 years after the Big Bang, when the universe first cooled enough for photons to travel freely. This radiation is the oldest light in the universe. It has been traveling toward us, in some sense, since the universe first became transparent. It washes over the Earth tonight, as it washes over the Earth every night, a faint signal from the beginning of everything. And all of this is what we sleep beneath. The dreamer, in their dark room, is not separate from any of this. The atoms in the dreamer's body were forged in the cores of stars that lived and died long before the sun existed. The water in the dreamer's blood is older than the planet beneath them. The carbon in their bones, the iron in their hemoglobin, the calcium in their teeth, all of it was assembled in some now-extinct nuclear furnace, scattered by some now-vanished explosion, gathered back together by the slow patience of gravity into the cloud that became the solar system. The dreamer is, in a real and not at all metaphorical sense, a small portion of the universe arranged into a particular pattern that, for a while, is capable of dreaming. When the dreamer dreams, the universe is, in some sense, dreaming about itself. Through this particular pattern of arrangements, this particular small fold of matter, the larger thing is producing experiences. The dream is the universe imagining what else it could be. This is not, strictly speaking, a scientific claim. It is a way of holding the picture in mind, but it has, perhaps, some quiet truth in it. The dreamer is not separate from the cosmos. The dreamer is the cosmos, doing something the cosmos does. Quantum mechanics, for all its strangeness, is among the most successful theories in the history of science. Its predictions have been confirmed to a precision that staggers belief. The behavior of every electron in every transistor, in every computer that has ever existed, is described by it. The interactions of light with matter, the chemistry of every reaction that has ever taken place, the structure of every atom that has ever been measured. All of this is described by quantum mechanics, and the descriptions match the measurements to many decimal places. And yet the interpretation of what the theory is saying about reality remains, after 100 years, contested. The mathematics is not in dispute. The wave function evolves according to a specific equation, the Schrödinger equation, which can be solved for any system one can specify. The predictions of the equation are reliable. What is contested is what the wave function is. Is it a real thing out there in the world that physically exists and physically evolves? Or is it merely a tool for predicting the probabilities of measurement outcomes, with no independent existence? The many worlds interpretation takes the first view. The wave function is real. It evolves continuously, deterministically, without any mysterious collapse. When a measurement is made, the apparent collapse is just the local entanglement of the measuring device, with the system being measured. An entanglement that, in the language of the theory, has the effect of separating the universe into branches that no longer communicate. In each branch, an observer sees a definite outcome. There is no contradiction. There are simply many observers, each in their own branch, each unaware of the others. Several modern physicists have continued to develop and defend this view. The Caltech cosmologist Sean Carroll has written extensively about it, arguing that the many worlds interpretation is the simplest and most parsimonious reading of the theory, because it requires no additional postulates beyond the basic Schrödinger evolution. The British physicist David Deutsch, who was instrumental in founding the field of quantum computing, has argued that the operation of quantum computers itself provides evidence for the many worlds view. A quantum computer, in Deutsch's analysis, performs its calculations by, in effect, distributing the work across many branches of the wave function, and then bringing the results together. The astonishing power of even relatively small quantum computers, which can in some cases solve problems that would take a classical computer the age of the universe to solve, is, on Deutsch's view, evidence that the other branches must be doing the work. Where else, he asks, could the computational resources be coming from? This argument is not universally accepted. Other physicists offer different accounts of quantum computation, accounts that do not require the literal existence of parallel universes. The matter, again, is open. But it is a measure of how seriously the many worlds interpretation is now taken that arguments of this kind are even being made by leading physicists in serious scientific contexts. The idea that there are many worlds, once a fringe speculation, has become respectable. What this means for the question of dreams remains, of course, undetermined. The many worlds interpretation describes branches that do not communicate. By the theory's own internal logic, the dream cannot reach into them. The branches are separated by decoherence, the process by which a quantum superposition, once entangled with a sufficiently complex environment, becomes effectively classical and can no longer interfere with itself. Once decoherence has occurred, the branches are sealed. Their existence is permanent, but their interaction with each other is, for all practical purposes, zero. This is the standard view, and it is probably correct, but it does leave open, in a quiet corner of the picture, the possibility that we have not yet fully understood. The mechanism of decoherence is now well studied, but it is not without subtleties. The relationship between decoherence and consciousness is even less clear. The role of the observer in quantum mechanics, which the founders of the theory wrestled with and never quite resolved, continues to provoke debate. We cannot say, with full confidence, what does or does not communicate with what. We can say only that, by the best science of our time, the branches do not interact in any way we have detected. That is a long way from saying that they cannot interact at all. And that small uncertainty, that small gap in our understanding, is where the old intuition continues to live. The intuition does not claim to be science. It claims only to be an experience, the experience of waking from certain dreams and feeling that one has just returned from somewhere. Science cannot yet rule it out. Science can only say that, by what we have so far measured, the experience is not pointing at anything real beyond the brain that produced it. And so we are left, again, with the question, and with no settled answer. There is a kind of dream that comes occasionally, more often to some people than to others, in which the dreamer realizes, while still in the dream, that they are dreaming. The realization is sometimes called lucidity. The phenomenon has been studied scientifically, beginning seriously with the work of Stephen LaBerge at Stanford University in the late 1970s. LaBerge devised a clever method of confirming the existence of lucid dreams. He trained himself, and later other subjects, to perform a specific pattern of eye movements upon becoming lucid in a dream. Because the eyes are not paralyzed during REM sleep, the eye movements can be recorded by an electrooculograph and matched with the dreamer's later report of when lucidity occurred. The technique works. The agreement between the recorded eye signals and the dreamer's account is too precise to be a coincidence. Lucid dreaming is real. What is it like to be lucid in a dream? The reports vary, but certain features recur. The dreamer notices something strange, often a small inconsistency in the dream environment, and the noticing somehow brings the critical faculties online. Suddenly, the prefrontal cortex, or some functional equivalent, has stirred enough to recognize the situation for what it is. The dream does not end. The dream continues. But now the dreamer is aware of being inside it. The colors often become more vivid. The sense of presence intensifies. Some lucid dreamers report being able to influence the dream's direction, to fly, to summon people they wish to see, to walk through walls. Others report a kind of reverence, a stillness, in which they do not wish to disturb the dream, but simply to observe it. The neuroscience of lucid dreaming is still being worked out. Brain imaging studies have shown that during lucid REM sleep, the frontal regions of the cortex become more active than they normally are during dreaming, while still less active than during waking. The brain enters a kind of hybrid state in which the dream-generating machinery is still running, but the self-aware machinery has partially rejoined the proceedings. The result is the strange experience of being both the dreamer and the observer of the dream, both inside and outside at once. For our purposes, what is interesting about lucid dreaming is that it confirms something important. The dream is not merely a passive replay of fragments. It is a generative process, capable of producing experiences detailed enough and coherent enough to support what is, in effect, a second mode of consciousness within itself. The brain is doing something extraordinary during REM sleep, something that, even when we are aware it is happening, we cannot fully account for. The capacity is real. The depth of it is genuine. The fact that it occurs every night in nearly every human being is one of the quiet wonders of our biology. Whether this generative capacity has anything to do with parallel realities, of course, remains the open question, but it is a capacity that takes the question seriously. If the brain were merely shuffling random images, the question would barely arise. The brain is not merely shuffling random images. The brain is constructing whole worlds with their own laws and inhabitants, and is doing so well enough that consciousness, in some form, can take up residence inside them. One of the most striking phenomena reported in connection with dreams is the experience of precognition, the sense of having dreamed about an event before it occurred. The scientific status of this phenomenon is, to put it mildly, contested. The mainstream scientific position is that precognitive dreaming is not real, that the apparent cases are explained by a combination of confirmation bias, faulty memory, and the sheer statistical likelihood. Given how many dreams are dreamed and how many events occur, that some coincidences will arise. This is a reasonable position, and it accounts for a great many cases. People do remember dreams that turned out to predict something, and forget the much larger number that did not. People do, on retrospective reconstruction, edit their memories of dreams to make them fit subsequent events more closely than they actually did. People do dream, every night, about many things, and given the volume, occasional alignment with future events is to be expected by chance alone. But there have been attempts to study the phenomenon experimentally, and the results have been more interesting than one might have predicted. Researchers at the Maimonides Medical Center in Brooklyn, in a series of studies conducted in the 1960s and 70s, attempted to test whether dreamers could incorporate into their dreams images that would only be shown to them after they woke. The results were statistically significant. The methodology was carefully scrutinized. The studies have been replicated with mixed results. The social psychologist Darrell Bem at Cornell University published a series of experiments in 2011 that appeared to show evidence of precognition under various conditions. The paper was controversial. Replications have been mixed. The matter is unsettled. It is important here to be honest about uncertainty. The mainstream of psychology and neuroscience does not accept precognitive dreaming as a real phenomenon. The statistical and methodological challenges of demonstrating it are formidable, and there is no proposed mechanism in current physics or neuroscience by which information from the future could reach a sleeping brain. By the standards of current science, precognitive dreams are not real. And yet the reports persist, in every culture, in every century, in vast numbers. The psychologist Steve Taylor and others have argued that the experimental evidence, taken as a whole, suggests some kind of small but consistent effect that warrants further study. Others, more skeptical, see the persistence of the reports as evidence only of the human tendency to find meaning in coincidence. The reader is free to weigh these views. For our purposes, what is interesting is that the question of whether dreams can reach across time, like the question of whether they can reach across branches of the wave function, is a question that has not been fully closed by science. The mainstream answer is no. The minority answer is maybe. The honest answer is that we do not know with full certainty, and that the experience of seeming precognition, like the experience of seeming to visit other worlds in dreams, remains a part of the human record that is older than science and has not been dispelled by it. We can sit with these uncertainties. They do not need to be resolved tonight. They have lasted thousands of years. They will last a while longer. There is something to be said, in closing this stretch of thought, for the simple act of paying attention to one's dreams. The brain, every night, offers each of us a private gallery of images, narratives, encounters, and landscapes. Most people allow it to vanish on waking. The images dissolve in the first cup of coffee or in the first glance at a phone, and the day takes over, and the gallery is forgotten by lunch. But it was there, It will be there again tonight, and tomorrow, and the night after. People who keep dream journals, who write down what they remember within the first few minutes of waking, often discover that they dream more than they thought. The act of recording the dream seems to reinforce the memory of it, and the memory of the previous night's dreams seems to make tonight's dreams easier to recall. There is a feedback effect. The more one attends to dreams, the more one has access to them. People who have been keeping journals for years report rich, detailed dream lives, populated with recurring characters and locations, with their own developing themes. What one does with this, of course, is up to the dreamer. The Jungian tradition would say that the dream is offering material from the collective unconscious, that the recurring figures and themes deserve to be engaged with, even dialogued with, because they reveal something about the deeper structure of the self. The Freudian tradition, somewhat differently, would interpret the dream as the disguised expression of unfulfilled wishes and unacknowledged desires. The activation synthesis school would say that the dream is the brain's attempt to weave a story from random neural noise, and that any deeper meaning is something the waking mind has imposed afterward. The memory consolidation school would say that the dream is a side effect of the brain's nightly work of integrating new experiences with old. The threat simulation school would say that the dream is a rehearsal for danger. Each of these views captures part of the picture. None of them captures it all. The dream, as a phenomenon, is large enough to support multiple interpretations without being exhausted by any of them. What seems to be true is that dreams reward attention. The dreamer who takes the dream seriously, who treats it as worth remembering and worth thinking about, often finds that the dreams in turn become more available, more coherent, more interesting. The dreamer who dismisses the dream as random nonsense often finds that the dreams in turn become harder to recall, less detailed, and easier to forget. The relationship between waking attention and dream content is not yet fully understood, but it appears to be real. The dreaming brain seems to respond to the interest of its owner. This, too, has been known in some form for a very long time. The ancient practice of dream incubation, in which a dreamer would sleep in a sacred place, hoping to receive a meaningful dream, depended on the assumption that the dream could be invited, that one's intentions could shape what would arrive in the night. Whether this is because the brain genuinely modulates its dream content in response to waking intentions, or because the dreamer becomes more attuned to noticing relevant material in dreams that would have occurred anyway, is a question that need not be settled here. Either way, the practice seems to work in its quiet way. The dream answers, in some form, the question one brings to it. We are deep in the night now. The hour matters less than the quality of the dark. There is a particular stillness that arrives in the small hours, when traffic has thinned and the wind, if there is any, sounds different than it does by day. The body knows this hour. The body has spent thousands of nights in this hour. The body is built for it. It is worth saying something here about the older traditions, the ones that did not have quantum mechanics and did not have neuroscience, but had nevertheless arrived at views of the dream that, in their own terms, were quite sophisticated. The ancient Egyptians, for instance, distinguished several different kinds of dreams. Some were considered to be messages from the gods, delivered directly and clearly. Some were considered to require interpretation by trained specialists. Some were dismissed as the residue of waking activity. The categories were not arbitrary. They reflected centuries of observation. The Egyptians were attentive dreamers, and they recorded what they noticed. The ancient Greeks, similarly, did not treat the dream as a single phenomenon. Homer, in the Iliad and the Odyssey, refers to two gates through which dreams enter the sleeper, one of horn and one of ivory. Dreams that come through the gate of horn are true. Dreams that come through the gate of ivory are false. This was not, presumably, intended as a literal description. It was a way of acknowledging that not all dreams are alike, that some bring something worth taking seriously and others do not, and that the dreamer's job, in part, is to learn to tell which is which. The ancient Chinese tradition, particularly in the Taoist school, took dreams as occasions for philosophical inquiry. The story of Zhuangzi and the butterfly is the most famous example. Less well known, but equally striking, is the broader Taoist suggestion that the boundary between dreaming and waking is itself an artifact of perspective, that we are all, in some sense, dreaming all the time, and that what we call waking is merely the dream we have agreed to share. The Tibetan Buddhist tradition developed elaborate practices around dreams, including techniques for becoming lucid within them, and for using the experience of dreaming as a training ground for the experience that, according to the tradition, will arise at death. The view here is that the mind, freed from its anchor in the body, will encounter experiences quite similar to those of dreams, and that practice with lucid dreaming can prepare one for navigating the larger experience well. Whether this view is correct is, of course, not something science can address. But the practice itself, the cultivation of awareness during sleep, has been the subject of recent neuroscientific interest, and there is no doubt that it produces real and measurable changes in the dreaming brain. The point of mentioning these traditions is not to suggest that they were right and that modern science is wrong. The point is that human beings have been paying close attention to dreams for a very long time, and the accumulated body of observation, while not scientific in the modern sense, is not without value. There are patterns, there are practices. There is a long human conversation about what dreams are and what they might mean, and the latest contributions to that conversation are arriving now, from neuroscientists and physicists and philosophers. But the older voices in the conversation have not stopped speaking. They are still there in the texts, in the traditions, in the quiet sense one has on waking from a particularly vivid dream, that one has just returned from somewhere worth having gone. Let us return one more time to the cosmos that surrounds all of this dreaming. The universe is old, about 13.8 billion years by the best current estimates. It started, according to the Standard Model, in a state of extraordinary density and temperature, often called the Big Bang. In the first fractions of a second, the cosmic inflation we discussed earlier may have occurred. By the time the universe was a millionth of a second old, it consisted of a hot soup of fundamental particles. By the time it was a few minutes old, the first light atomic nuclei had formed, hydrogen and helium, and a small amount of lithium. By the time it was 380,000 years old, it had cooled enough for those nuclei to bind with electrons into neutral atoms, and the universe became transparent. The light from that moment is what we now see as the cosmic microwave background. Then came the long, slow age of the first stars. The universe was dark for many millions of years, while gravity did its quiet work of pulling the slightly denser regions of gas together, and the densest of those regions ignited as the first stars. These early stars were enormous, hot, and short-lived. They burned through their fuel quickly and ended in supernova explosions that scattered the heavier elements they had forged in their cores. Carbon, oxygen, iron, the elements that would eventually become the chemistry of life. Successive generations of stars enriched the interstellar medium further. By the time the Sun formed, around 4.5 billion years ago, the local cloud of gas and dust contained enough heavier elements to permit the formation of rocky planets. The Earth coalesced from this cloud, and over the next billion years or so, the conditions arose for the first simple life. Whatever exactly happened, life emerged. It diversified. It eventually produced, after another 3 or 4 billion years of patient evolution, brains complex enough to dream. This is an extraordinary sequence. Each step required the previous step. The chemistry of life required the heavier elements forged in stars. The stars required the gravitational clumping of an earlier generation of cooling gas. The cooling gas required the initial conditions established in the first moments of the Big Bang. Change any of these parameters, and the chain breaks. There is, in the standard models, no obvious reason why the universe should be tuned in such a way as to permit dreaming brains to arise within it. And yet here we are. Some cosmologists take this fine-tuning as evidence for the multiverse. If there are many universes with different parameters, then it is unsurprising that we find ourselves in one of the rare ones where the parameters permit life. Most of the other universes are sterile, lifeless, doomed to expand too fast or collapse too quickly, or never produce stable atoms in the first place. The few that allow life, like ours, are the only ones that have anyone in them to remark on the apparent miracle. This is sometimes called the anthropic principle. It is, in part, an admission that we cannot explain our universe's particular tuning from within physics alone, and that perhaps the explanation lies in the larger ensemble of which our universe is one example. Others find the anthropic argument unsatisfying. It feels, to them, like a refusal to look harder for a deeper explanation. There may be, on this view, some yet undiscovered principle of physics that picks out the parameters we observe, in which case the apparent fine-tuning would not require a multiverse at all. The matter is unresolved. It will, perhaps, remain unresolved for a long time. But whichever way it eventually settles, the picture in which we find ourselves is extraordinary. We are a particular pattern of complex chemistry, on a small planet, orbiting an ordinary star, in one arm of an ordinary galaxy, in a vast and possibly infinite cosmos that, at small scales, behaves in ways no human intuition is built to grasp, and that, at large scales, contains more variety and possibility than any single mind can hold. And every night, for an hour or two, the patterns of our brains generate experiences of being elsewhere, of being other people, of being in places that do not exist or did not happen, of encountering figures who feel both unknown and ancient. The match between the largeness of the outer cosmos and the largeness of the inner experience is striking. Neither, alone, would be quite as wonderful. Together, they form one of the great quiet symmetries of being alive. There is something else worth considering before we begin to draw the night toward its close. It has to do with time, and with how strangely time behaves inside dreams. A dreamer, lying in bed, may experience what feels like hours of adventure during a period of REM sleep that, by the clock on the bedside table, lasted only 15 or 20 minutes. The dream contains, in its own internal sense, long conversations, journeys across landscapes, sequences of events that, if they had occurred in waking life, would have filled a substantial part of a day. And yet, in the brain, the whole experience has unfolded inside a short window of physical time. The subjective duration of the dream does not always match the objective duration of the REM episode. This is not a precise rule. Some dreams seem to last about as long as they take. Others compress or expand time in ways that the dreamer can only notice on waking. Some dreams contain time loops, returns to earlier scenes, sudden jumps forward into futures that the dream itself does not bother to explain. The temporal logic of the dream is its own logic. It is not the temporal logic of the world. This has long been noticed. The French novelist Marcel Proust, in his great work on memory, devoted some of his most beautiful pages to the strangeness of dream time. He described how a dream that seems, from the inside, to encompass a whole vacation, with weeks of sun and sea and slow afternoons, can be compressed into the brief interval between two sounds in the waking world. The dream, in this sense, has invented an entire stretch of time that did not exist. Or, more carefully, the brain has generated, in a brief period of physical processing, the experience of an extended duration that did not correspond to any external clock. What this means for the nature of time and for the nature of experience is not a small question. If the subjective sense of time can be compressed and expanded by the brain so dramatically, then the time we experience while awake may also be, in subtle ways, a construction. There is independent evidence for this. The perception of time is known to vary with attention, with emotion, with chemistry. A moment of intense fear can stretch into what feels like a much longer period. A pleasant afternoon can vanish in what feels like minutes. Time, as experienced, is not quite what time appears to be when measured by a clock. The clock is consistent. The experience is not. Some philosophers and physicists have wondered whether this difference between measured time and experienced time might point to something deeper. In modern physics, time is not what common sense takes it to be. In Einstein's theory of general relativity, time and space are woven together into a single four-dimensional fabric called spacetime. And what we call the passage of time is, in some sense, just the slope of our trajectory through that fabric. There is no universal now. Different observers, moving at different speeds or sitting in different gravitational fields, disagree on which events are simultaneous. The flow of time, the feeling that the present is moving from past to future, has no clear place in the equations. The equations describe a four-dimensional structure in which all moments coexist, with the past and future as real, in some sense, as the present. This is sometimes called the block universe view, and it remains controversial. Not all physicists accept it, but it is a serious consequence of the mathematics of relativity, and many physicists do accept it. On this view, the past has not vanished. The future has not yet arisen. They are simply elsewhere in the structure, the way other rooms in a house are elsewhere, even when one is not in them. The sense of time flowing is a feature of how consciousness moves through the structure, not a feature of the structure itself. If something like this is correct, then the strange time of dreams becomes less surprising. The brain, freed from its usual constraint of moving forward through time at a steady rate, can wander. It can revisit. It can compress and expand. It can construct experiences whose temporal logic is local to itself. The dream is, in some sense, an exploration of what experience would be like if the ordinary scaffolding of time were not in place. And the fact that the dream can do this, that the brain can generate convincing experiences of duration that do not match physical duration, suggests something about how consciousness and time fit together that we do not yet fully understand. It is not a long step from here to the question of whether the dream might, in some way, touch parts of the four-dimensional structure that the waking mind does not. We cannot say that it does, but the picture provides, again, a kind of conceptual room for the old intuitions. If the past and future are real in the way the present is real, then perhaps the dream's occasional sense of having visited a future event, or a past one not personally experienced, is not entirely a confusion. We do not have a mechanism. We have only a picture that allows the question to remain serious. And the question remains serious. It has remained serious for as long as human beings have been writing things down. It will, presumably, remain serious for a long time yet. We are nearing the end of this long journey through the dark. The ideas have, in their way, come back around. We began with the question of whether dreams might glimpse parallel realities. We have moved through the neuroscience of sleep, through the long debate over the interpretation of quantum mechanics, through the cosmology of inflation and the multiverse, through the older traditions of dream interpretation, through the strange phenomenon of lucid dreaming, through the contested question of precognition, and through the quiet wonder of being a small pattern of matter that, somehow, is capable of all this thinking. The literal answer remains the same. By the standards of current science, dreams are not glimpses of parallel realities. They are productions of the dreaming brain, drawing on local materials. The other branches of the wave function, if they exist, do not appear to communicate with our branch. The other regions of an infinite universe, if it is infinite, are too far away to reach us by any known mechanism. The dream is not, in the literal physical sense, a window onto somewhere else. And yet the dream is undeniably an opening. It opens onto the brain's vast capacity to model alternative realities, to rehearse, to remember, to imagine, to encounter. It opens onto the deep history of the species, the patterns laid down by countless generations of evolution. It opens onto the personal history of the dreamer, the memories that the conscious mind has set aside, but that the unconscious has kept. It opens onto the strange architecture of consciousness itself, that quality of being aware that we still cannot explain, even after centuries of trying. The dream is an opening. The dream is the brain, in private, letting through what it cannot let through during the day. And perhaps that is enough. Perhaps the wonder of the dream does not require the literal existence of parallel realities to be wonderful. Perhaps it is enough that, every night, each of us spends an hour or two as a kind of internal explorer, walking through landscapes assembled by the most complex object we have ever encountered, our own brain. Perhaps it is enough that the experience, while it lasts, feels real. Perhaps the meaning of the dream is not what it points to outside the brain, but what it tells us about what the brain itself is capable of. Or perhaps, if the older intuitions are quietly correct in some way we have not yet figured out, the dream is also more than this. Perhaps there is some subtle channel, not yet detected, by which the branches of the wave function whisper to one another, faintly, in the deep parts of the night. Perhaps the dream, in some small way, is touching something that the waking mind cannot. We cannot say. The science of our moment does not support this. The science of our moment does not absolutely rule it out. The matter, like so many of the matters we have considered tonight, is open. The thing to do, perhaps, is not to insist on an answer. The thing to do is to let the question rest, gently, in the dark room with you. Let it be what it is. Let it be a question. The question is older than any of the answers we have offered or will ever offer. The question has accompanied human beings for as long as human beings have slept and dreamed. The question will outlast our scientific moment, and the moments after that, and probably the species itself, and probably the Earth, and possibly the Sun, and maybe even, by the lights of certain cosmological models, the universe. But it will not outlast the night. The night has its own scale. The night is finite. The night is, in some sense, the smallest cosmic unit, and within the night the dream comes and goes, and the dreamer comes and goes, and the morning eventually arrives. There is one more thing worth saying before we let the rest of the night carry us forward. It has to do with the company we are in. The species we belong to is, by every measure we have, the only one we know that asks these questions about itself. Other animals dream. Other animals are conscious, by every reasonable inference. But other animals, as far as we can tell, do not lie awake wondering what dreams are, or whether the universe is one of many, or whether the structures of the cosmos and the structures of the mind might be connected in ways we have not yet understood. We are the species that asks. We are the species for whom the question is part of the equipment. This is a strange and quiet honor. It comes with no guarantees. We may never answer these questions. We may, as the species, vanish before any of them are settled. The whole long history of our wondering may turn out to be a brief episode in the larger life of the planet, a chapter that will close when the conditions that produced us shift in some way we have not anticipated. None of this is certain. None of it is required. But while we are here, we get to ask. We get to lie in the dark and wonder. We get to fall asleep and have the dream and wake up and remember some part of it and spend a moment in the soft early light considering what it might have meant. That is not a small thing. It is, in its quiet way, one of the things that makes a human life worth having. The questions are part of life. The wondering is part of the wakefulness. And the dream, whatever else it is part of the rhythm by which the wondering renews itself. So sleep, if you can. Let the brain do its long, patient work. Let the day's experiences settle into their places. Let the deep machinery of memory consolidation and emotional regulation and threat rehearsal and whatever else is happening go about its business in the dark. Let the dream, when it comes, come. Watch it, if you remember any of it. Forget it if you do not. Either is fine. Either is good. Tomorrow or the day after that, you may wake from a dream that does not feel like a dream. You may have a strange morning sense of having just come back from somewhere. You may wonder, briefly, where you have been. You may, in some quiet corner of your mind, suspect that somewhere is real, in some way that has not yet been fully described by science. You will not know for certain. Nobody will. The question will sit with you, as it has sat with every dreamer in every culture for as long as there have been dreamers. And then you will get out of bed and put on the kettle, and the day will begin, and the question will recede to wherever questions like this live during the daylight hours. And the next night, when sleep comes again, it will be waiting. The constellations move slowly across the sky. The earth turns, and the stars that were rising at the eastern horizon when sleep began are now high overhead. By the small hours, the winter constellations, if it is winter, are in their full glory. Orion stretches across the southern sky, his belt of 3 stars almost impossibly precise. Below him, the brightest star in the night, Sirius, burns a sharp blue-white. Above and to the right, the Pleiades, that small cluster of 7 or 8 visible stars that have featured in the mythologies of nearly every human culture, ride high. These stars are part of the same vast structure we have been considering. Each of them is a sun, similar in many ways to our own, with its own complement of planets, its own history of formation, its own future of cooling or collapsing or exploding. The light from them is old. The light from Sirius is about 8 years old. The light from the stars in the belt of Orion is hundreds or thousands of years old, depending on which star one looks at. The light from the Andromeda galaxy, the nearest large galaxy to our own and visible to the naked eye on a dark night, is about 2.5 million years old. It left Andromeda when our hominid ancestors were just beginning to use stone tools. All of this light, ancient and patient, is reaching the earth right now. Some of it is falling on the window of the room where the dreamer sleeps. Some of it is being absorbed by the leaves of trees that the dreamer planted, or that someone else planted long ago. Some of it is filtering through the atmosphere, scattering off molecules of nitrogen and oxygen, illuminating the few wisps of cloud that may be drifting overhead. The light has come a very long way to be here. It will continue, after passing through this moment, out into the world, where some small portion of it will be absorbed, and the rest will travel on, carrying its message of long ago into still further futures. The dreamer asleep is not aware of any of this, but it is happening above the room. The cosmos is doing what the cosmos does. The light is moving. The galaxies are rotating. The expansion is continuing. The vast and indifferent processes that have produced everything, including the dreamer, are continuing without pause. The dream is a small thing inside an enormous quiet. And yet the dream is also, in some sense, the answer the universe gives to itself when it wonders what it is. The dreamer, dreaming, is the universe imagining. The patterns of light that the brain generates in sleep are the universe rehearsing its own possibilities, sampling its own range, exploring, however briefly, what it might be like to be other than what it is. This is, of course, a way of speaking. The universe is not literally conscious. The dreamer is not literally a probe sent out by the cosmos. But there is a sense, a quiet sense that does not need to be defended too strongly, in which everything we do, every thought we have, every dream we wander through, is something that the universe is doing through us. We are made of the stuff of stars. We are arrangements of that stuff that, for a while, have the capacity to ask what the stuff is for. The asking is part of the universe. The dream is part of the universe. The whole long human conversation about what it all means is part of the universe. And the universe is, in a sense, listening to itself when we listen to each other. If that is the case, even loosely, then the question of whether dreams are glimpses of parallel realities becomes a question the universe is asking itself. And whatever the answer turns out to be, the asking is already a kind of answer. The cosmos that produces dreamers who wonder about parallel realities is, by that very fact, a cosmos in which the question is real. Let us close, then, with quietness. The night is long. There is time. Whatever has been thought tonight does not need to be remembered tomorrow. The mind, in sleep, will sort what is worth keeping from what is not. The dream, if it comes, will come on its own schedule and will be what it will be. The old question will still be there, in its proper place. The old human suspicion that dreams open onto something larger than the dreaming brain has not been refuted, only set in context. The science that surrounds it has grown, and the picture has grown stranger and richer than any of the ancient dream interpreters could have imagined. The universe of branches in the wave function, of pocket universes in eternal inflation, of regions far beyond our cosmic horizon, where identical copies of ourselves may already be carrying out their lives, is a universe in which the old intuition has somewhere to live, even if science cannot yet point to the precise mechanism by which it would be confirmed. So if you find yourself, on some morning to come, having returned from a dream that did not feel quite like a dream, you may sit with the experience for a moment. You may notice the way the room looks slightly different when the dream is still close. You may notice the strange certainty that you have just been somewhere, even though you know that you were here all night. You may let the question rise quietly in you. Was it real in some sense I do not yet have words for? Was it a place? Was someone else, somewhere else, also there? And then, when the question has done what it does, you may let it settle and reach for the morning and let the day begin. The dream will not be the last one. the night will come back. The brain will do its work again. And the small private theater behind your eyes will open, as it has opened every night since you were born, and the show, whatever it is, will go on. The light is ancient, the brain is intricate, the universe is vast, and the dreamer between them is held by all of it gently for as long as the night lasts. Rest well. Let the questions rest with you. Let the dream, when it comes, come. If this gentle journey through the night has helped you drift off, or simply offered some quiet company on a wakeful evening, please consider leaving a like and subscribing to the channel. There are more long, slow walks through the deep places of the cosmos waiting in the dark. For now, though, let the rest of the night carry you forward. Let the dream open in its own time, and let whatever questions remain rest, soft and unhurried, until morning. Good night.